is Unit 910, looking for relationships. We're working on some material here in Block C. By the end of this lesson, what we want to be able to do is describe data using one of two terms. It's either going to be discrete or continuous, and we'll look at what those terms mean as we go through the lesson. And we also want to be able to determine unknown quantities from a graph using either interpolation or extrapolation, and we'll look at what those two terms mean. Before we go on to this lesson stuff, let's just take a look back at what we did in the previous lesson. Okay, we plotted a scatter plot of liters of gas on the horizontal axis and cost on the vertical axis. Plotted a scatter point, nice little points. And then to emphasize the trend, I drew this straight line through all of the data. And then I picked this point in between all of the data points. And I said that this red point in here represented the fact that if you bought 42.5 liters of gas, it would cost you $53.1. I could draw that solid line between all of those points and just pick a point on that line and know that it represented a value for liters and a value for cost because of what kind of data I was plotting here. The data that I was plotting there is what we would call continuous data. So in the graph in example 1, we could connect the data points with a solid line because it's possible for our variables, i.e. cost and the number of liters, to have any values in between those that we had plotted. So I could have 40 liters of gas that I'd purchased, or 50 liters, I could have 45, I could have 45.2. It could take on any kind of number value in between those ones that I had plotted. Okay, so I connected those as a solid line to indicate that I can have sort of any sort of value in there. If only some of the values of our variables are allowed, the data is what we call discrete, and then we connect the points with a dotted line to reflect the fact that all of those values in between aren't necessarily filled in. This is a little bit more clear if we take a look at an example here. So the previous lesson was example 1, this is example 2. My daughter had her birthday party at a bowling alley. As children arrived at the party, they took their bowling shoes out of a big bin, and I kept track in a table here of the number of shoes in the bin and the number of people at the party. Okay, I just wrote down those two numbers in this table here, and now I'm looking for a relationship between these two quantities. So first question, what are the variables? Well, they're listed right in the headings of our table here. They are the number of shoes left and the number of people at the party. So is there a relationship between the number of shoes that are left in the bin and the number of people at the party? Now, next we want to figure out which one of these is our dependent variable and which of these is our independent variable. And the way we do that is we try filling in the blanks in this sentence. Blank depends on blank. So does it make sense to say that the number of shoes left depends on the number of people at the party? Or does it make more sense to say that the number of people at the party depends on the number of shoes left? Okay, try this back and forth a little bit, and I think it makes sense to say that the number of shoes that are left is going to depend on the number of people who are there. Okay, as people come, they take shoes out, so the number of shoes is going to decrease. So because shoes depends on people, the dependent variable must be number of shoes. That means the independent variable has to be the other one, number of people. And I do this because it tells me how I want to set up my graph. If number of shoes is the dependent variable, it's going to go along the side of my graph. And number of people is going to go along the bottom. So let's go ahead and plot this graph. So as I said before, I'm going to have number of people down here. I'm going to have number of shoes up here. I look at number of people and I see that the biggest number of people I have is 13, so let's choose a nice little scale here. I always start at 0. One box can just represent one person, so I'll just label every other one. 2, 4, 6, 8, 10, 12, 14, 16. That's far enough. but I can go a little bit further here, 18, 20. And let's see, going down up the side, my number of shoes left has to get up to 32. I know that I have 20 boxes here because all of these grids that I'm using are 20 by 20. So a good scale would be going up by one box represents 2. So I'm just going to do every other one. So I'm going to go up 4, 8, 12, skip to 16, skip to 20, 24, 26, 28. Nope, and I messed up there, so I got to go back, fix this. So I do 12, 16, 20, 24, 28, 32, 36, and yeah, 40 up at the very, very top. So each box here along the side represents 2 shoes. All right, let's fill in our graph here. Number of people, when it was 3, we were at 32. When it was 6, we were at 26. When it was at 8, we go up to 22. When it's 9, we are at 20. And when 13 people are at the party here, we are at 12 shoes left. So that's got to be 13 and 12 right there. Okay. So first off, let's describe this relationship. Well, we always talk about first about what's going on the x-axis or the horizontal axis. So we can say as the number of people increases, what is happening to the number of shoes? Well, the number of shoes, it looks like it is going down. Here's my trend. It starts up at the top and it sort of goes down as we go left to right. As the number of people increases, number of shoes decreases. Let's fix that. Number of shoes decreases. So the other thing we might say is that this is a downward trend. Because as we go from left to right, our points are kind of going down. Now, to illustrate this trend, we can draw a line. But as I said earlier, this is what we call discrete data. So we are going to draw a dotted line here. So let me just emphasize that this is going to be a dotted line. We will make this a dotted line right there like that. And then we will come over here and we'll draw a nice little dotted line to illustrate our trend here. And I seem to have missed. So fix this up a little bit here. There we go, just like that. So it should go through nicely through all of these points right here like this. There we go, that's a little bit better. Okay. Now, we've drawn a dotted line because it doesn't make sense to think about having any possible value in between the ones that we've plotted. So for instance, if we're thinking about the number of people, we've plotted points here for what happens when we have sort of 9 people and 8 people. But we can't really have a point in between there. We couldn't have a point that represented 8.5 people because we don't have 0.5 of a person. It's also not possible on our shoes axis to have something like 23.57 shoes because shoes only come in sort of whole numbers. Okay? So this makes our data discrete, so we connect it with the dotted line. Now, how can we use this line here? Well, we can use it to do one of 2 things, what is called interpolation or extrapolation. Okay? Here's the kind of question that involves interpolation. How many shoes were in the bin when 11 people were at the party? So we answer this question by they're giving us people at the party. So we go to the number of people axis and we find 11. 11 people at the party. And what we want to do is from 11 we want to go up to our line that we've drawn. And then from our line we want to go across to the other axis. Okay? Because it's asking me how many shoes were in the bin. It's this axis on the side here that tells us the number of shoes. So when 11 people were there, we go up and across, we see that there were 16 shoes in the bin. Now this is called interpolation because it is inside the data that we've plotted. We've got these black data points on either side of this point that we've got in the middle here. Okay, we've got this point here and this point over here. So it's kind of inside the data. Our next question here is an example of extrapolation. If there are 2 shoes left, how many people are at the party? Well, let's see. They're telling us that there are 2 shoes, so we go to the number of shoes axis and we find where 2 would be. Just as we did before, we're going to go along until we get to our line of best fit, and then we're going to head down to our number of people axis, because they're asking us how many people are at the party. So where did we come down on our number of people axis? Well, we ended up at 18. So if there are 2 shoes left, there should be 18 people at the party. Now, why is this called extrapolation? Because notice our data points are here, 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 and here. We're beyond where our data is. Okay, we're out at larger numbers than what we had in our table. So this is kind of beyond the data, or extra to the data. So we call this extrapolation. So those are the 2 big concepts: interpolation and extrapolation, discrete data, and continuous data.